Hello and welcome to another sedimentological seaside story with me, Greg Samways. This is a story inspired by a sign. I can't remember where I was now, but I was in a coastal city somewhere, it may have been in Portugal actually, where I saw a sign next to a drain in the road that said the sea starts here. And I knew exactly what that meant because I'm a sedimentologist. I study sediments and how rivers flow from the land into the ocean. But I wondered how many other people knew just what sort of impact they could be having on the oceans by throwing their litter in the street. So what I aim to do here in this presentation is just show you how your litter in the street can get washed hundreds of kilometers out onto the ocean floor into water that is 4 kilometers deep. And I imagine while you're sitting in a cafe on a roadside in a city somewhere, you wouldn't really be thinking that that is possible. So let's go and find out how that might happen. So we're going to start our story way out in space, looking at that pale blue dot that we live on. And just think about how much more care we should be taking to look after the only planet we have. So let's zoom right in, and today we're going to go into California, and in particular I'm going to be looking at the Monterey Canyon. So we're quite familiar with the land, and we go to the coast, we go to the beach. But how often do we think about what is beneath the waves? And you can see here in Google Earth there's a huge amount to be seen beneath the waves. But what is it? I mean, this clearly looks like a canyon, and that's exactly what it is. It's a canyon which is running off of the shelf and running way out onto the seafloor. But what interests me with this canyon is how it's almost connected to the coastline. There's literally only a kilometer between the coastline and the head of this canyon. And this is a lovely little place here, Moss Landing. You could imagine going here to the boatyard, to a cafe somewhere, and dropping your litter on the street. And what's going to happen to that litter? It's going to go down the storm drains, it's going to get washed into the river, it's going to find its way into the sediments, onto the beach, where it's going to be churned up by the waves and the tides, and eventually that plastic, that sediment, could find its way into this canyon. So the sediments here around the coastline, around the shelf, are being constantly moved by the tides and the waves, and that sediment can be washed across the seabed and find its way into the canyon. So the sediments start to build up on the canyon walls, and then eventually what happens is the canyon wall becomes unstable. And imagine in this canyon, you can see these features on the sides of these canyons. This is where sediments have broken off and rushed down into the canyon. Imagine an avalanche. I'm sure you can imagine avalanches on mountainsides. Well, we have a similar thing happening in the deep ocean. This is actually up on the shelf here, but in the canyon, you can imagine the erosion which is causing sediment to rush down in an avalanche into this channel in the base of this canyon. But what you probably don't realize is once that sediment has found its way into the canyon in a huge rush, it then becomes what we call a turbidity current. And it flows through the channel along the seabed. A bit difficult to imagine, but in fact a turbidity current is just a slightly denser fluid, denser than the water. So where does it go? It goes into the deepest part of the ocean, it goes into the canyon, and it erodes the canyon, it makes the canyon deeper, it destabilizes the walls of the canyon, and more sediment falls in, and that turbidity current runs all the way down through the canyon and out onto the sea floor. Before we start trying to follow the turbidity current out onto the ocean floor, I think we ought to just take a look at some turbidity currents, just to make sure we know what we're talking about. I think everybody understands an avalanche, but you may not be familiar with turbidity currents. Here's an experiment in the laboratory with a flume showing a dense liquid, probably a milky substance full of sediment, rushing down the seabed and spreading out onto the basin floor. This is a turbidity current. This is how sediments get from the shelf onto the ocean floor. And you can imagine that sediment-laden turbidity current full of plastic. Now we have a clearer idea of how the avalanches, the debris flows in the canyon head get sediment into the canyon, and we understand now what a turbidity current is. That sediment-dense flow is going to flow all the way down through this canyon, eroding as it goes, maybe destabilizing more sediments in the canyon walls. And it's joined by other canyons, this Sockwell or Soquel Canyon here. And if we zoom out, we can see another canyon coming in from the south and joining up on the journey of this turbidity current, flowing all the way down through this canyon. The canyon extends off the shelf, down over the slope, down to the base of the slope, and there are some very big meanders, like river meanders, in this canyon as well. And this one here, very well known meander called the Shepherd Meander. And what we can see happening here is the really big flows are actually so big, they're what we call overtopping the canyon wall. So you can imagine that turbidity current is spilling over the top of the bend, and it's formed almost waterfalls on the seabed as it cascades down over the slope. The smaller flows, meanwhile, are probably still following the canyon, and this is going on for literally hundreds of miles. We can see that canyon extending all the way out across the basin floor, meandering around this Davidson seamount. So these are volcanic seamounts in here. The channel is having to find its way through the gap, and eventually we lose it way out here, literally 300 or 400 miles away from where it started on the shelf. And that's pretty incredible. So the rubbish that we drop in the street in a coastal town, which washes into the drains, I think you can see how it might possibly now, through turbidity currents, be driven all the way across the shelf, down the slope, and out into the deep ocean through these canyons and meandering channels. Really quite amazing what sitting outside a cafe eating a lolly can do to the ocean. While I'm here, I'll just recount another little story. You can see very often these straight lines going across the seabed. And of course, there are whole websites full of conspiracy theories about how these must be tank tracks by Russian submarine tanks that are desperately trying to invade the United States by crawling along the seabed. In fact, what these are actually the navigation, the survey tracks of the ships that do the bathymetric surveys that measure the depth of the oceans. So we just get a little bit more detail along these ships' tracks, which is why we get these crisscrossing lines. It's quite funny as well. While I was teaching in Dubai, I was teaching a group of Russian geologists, and I told them the story about the American conspiracy theory that these were Russian submarine tanks, and all of the Russian students I was teaching all started laughing. I said, "Oh, I'm sorry if I've offended you. Why are you laughing?" And they said, "Well, in Russia we have a conspiracy theory that they are American submarine tanks trying to invade Russia." So it works both ways, obviously. But I do encourage you, hopefully that's inspired you to go and look at Google Earth and go and find your way along these coastal zones, these coastal shelves, these shelf edges. There's such a huge variety of processes going on here, and there's always something new to see.